All right, well, we're going to try this podcast without the PowerPoint. For some reason, it doesn't want to load up. So we'll see how far we can get here. We are on section 1.8, and this is on combining functions. And the combining could be adding, subtracting. It could be all the basic operations, and then we're also going to throw in a composition of functions also. So some of the notations that you'll see, let's say we want to add two functions together. So you might see it like this, f plus g of x, and that means that we're simply adding the two functions together. So either one of these notations is correct. In this book, you'll see it written like this. So likewise, we can subtract functions. So it means the same thing. And we can also multiply and divide. So for multiplication, you're going to see, oops, come on. You're going to see this, and you may or may not see it with parentheses around the x also. And then division will look something like this. Okay? So if I looked at some examples of that, let's say we have the function f of x, and we're going to let him equal 3x minus 1. And then we're going to take a second function, a different one, so we're going to give it a different name, so we'll label it g of x. And let's say that is x squared plus 2x minus 1. Okay? So if we're looking for f plus g of x, that simply means we're going to add those two functions together, and then we're going to simplify it as we go along. So when we're adding, there's only one x squared term, so we'll write it first. A 3x and a 2x added together gives us a 5x, and a negative 1 plus another negative 1 gives us negative 2. If, however, we wanted to subtract, so we are taking the first function, so I'll put it in parentheses. So we want 3x minus 1 minus then the g of x, and so we're subtracting that whole function. And then, of course, we would want you to simplify it. So you have to remember here, because I'm subtracting the second function, that we have to distribute that negative sign. So we would have 3x minus 1 minus x squared minus 2x plus 1. So a 3x and the 3x minus the 2x is a 1x, so we have negative x squared plus x. Okay, so that would be f minus g. And then multiplying, of course, if we had to multiply these two functions, that would take a little more work because we'd have to double distribute, the f of x. So we'd distribute the 3x and then the negative 1. But we can multiply these functions and we can add those functions together. All right. I also want to show you here, maybe we'll go on to the next one. I also want to show you, though, that if we have, let's say, f of x is equal to x squared, and g of x is equal to 2x. Okay. If they have, let's say, f plus g of x, we know that we would just add those two functions together, and we would get x squared plus 2x. So we can't do anything else with that. We can't simplify it. And we can't evaluate it because they didn't give us a number to evaluate it for. So if, instead of leaving the x out there, they put in a value, let's say this, then that means we have to come up with the value of the function at that point. So we can go up here then and substitute in the 3 for the x. So 3 squared is 9, 2 times 3 is 6, So that would be 15. So when we evaluate even a sum or difference or product or something of a function and there's a number there, a constant instead, then you go ahead and evaluate it for that. Okay. Now, let's talk about composition of functions. So a pretty simple example would be, let's talk about Allie. We know that Allie works at Kid 7, and let's say that she makes $7.80 an hour. And she gets paid every 2 weeks, so over the course of the last 2 weeks, maybe she worked 28 hours. So it's time for her paycheck to come, and she's all excited because she knows that she's going to make, when you multiply those two together, $218.40. But she gets her check, and oh no, it's not in there. She doesn't have that much money. It's less than that. So there's something else that's going on with that. So after they figure out what her gross pay is, then they figure out then how much goes to Social Security and how much to state and how much to federal and all of this. They take all these deductions out. Well, let's say that altogether she had deductions equaling maybe 25% of her actual pay that she gets. So if they're taking out 25%, then what she's taking home, or what she gets to keep, is actually 75% of what she grossed. Okay? So we have two different functions going on here. Let's say one of the functions is the hourly rate. So f of x is going to equal 7.8x. So the value of this function is telling us what her gross pay is. So you just take the number of hours worked times 7.8. Then we have another function that we have to apply. And let's say this function then is taking out all of those deductions and seeing that she's only left with 75% of her check. Okay? So we have these two functions. Well, in order for this to work right, you do it. There's only one way to do it. You have to find how much she makes with her hourly rate, first of all, and then after you see how much she makes, then you take out the 25% or write her a check for 75% of that. Okay? So we want to do the inside function first, and that's the f of x. We've got to find out how much she makes altogether, and then after we know that, we take that amount and we plug it in to the g of x, because then we take it times 75%. All right? Well, this is known as a composition. Here's one way of looking at it, and another notation for it is f, and it's an open circle. So you have to pay attention, close attention to that, because it looks a lot like this, which is simply multiplying the two functions together. So one of them is just a multiplication sign, and the other one is a composition. So you have to pay close attention. Okay? And in our case, our composition would have to be G composed of F. Okay? So we have to know the inside function first. So that's an example of composition. So let's try it out with this example. Let's say that we have the function f of x is equal to x plus 2. Okay? And then we also have g of x. And let's say g of x is x squared. All right. Well, let's do this composition first of all. Let's do f composed of g is what we want to look for. So what we're doing is we're substituting in the second function, the g of x, the whole function, in place of the x in this function. Okay? So our g of x is x squared, and we plug in that x squared into the x, or all of the x's, whatever the case is, in the first function. Okay? So once again, here's like the outside function, but what we have to do is figure the g of x first of all, and then we plug it in for the x here. So this would be x squared plus 2. So this would be this composition. If we switch it around and go g composed, oh, I didn't make it an open circle, g composed of f. Here's another way of writing it, g of f of x. So you start with the inside function first, like in the case that we just talked about, is figuring out how much you are making with your hourly rate. So you take how many hours you work times your hourly rate. That is our inside function. So that has to be calculated first, and then you take that and plug it into the x in the other function. So if we switch this around then, the f of x, we're going to plug into the g of x. Okay, so g of x is equal to x squared so then g composition f of x is going to be where I take out the x in the g function, the first function, the x squared, take out the x and replace it with the function for f, and the function for f is x plus 2. Okay, so this function yielded this, and this function, when we switched the order of them, yielded this. So you can see that they're not necessarily the same thing. So let's try some compositions of, let's do another composition one then. So let's say that f of x is equal to 3x, g of x is equal to the square root of x plus 2. All right, we're going to do f composition g of x. So we're going to look at this one first of all. Oh, and we need an x there. Is equal to. All right. So we're replacing the second function in for the x in the first function. So here's our second function, square root of x plus 2, and that is being replaced in for the x in the outside function. Okay, so we need 3, and instead of x, we take it out and replace it with the square root of x plus 2. Whereas if we did g composition f of x, okay, we start with, well, the inside function, the 3x, is going to be substituted in to the x in the first fraction, in the first function, the g one. So we are going to take the g function, the square root of x plus 2. We're going to take out that x value and replace the x value with the f of x function, which is 3x. Okay, so you can see, in this case, we didn't get the same answer for that one either. All right, let's try decomposing now a composite function. Okay, so let's say, so this is called decomposing. Well, it didn't look like it was spelled right. I guess that's right. Decomposing a composite function. So let's say that you're a sales rep for a clothing manufacturer. You're paid an annual salary, plus you get a bonus of 3% of your sales over 500. So 500,000. So 3% of sales over 500,000. Okay, so we have to do, just to look at the bonus, just to look at how much our bonus is. Okay, the first thing we do is see if we have sales over 500, and if we do, we take that amount and subtract off 500,000 from it, because we only make it on sales above that. So we have to see how much above that we are, and then after we figure that out, then we take 3% of it. Okay, so one of the functions has to be done first. So let's say that the f of x is where we find the 3%, and then let's say g of x is going to be the function where we find out how much over 500,000 we have gone. Okay, so if we had to write this then in with the composition notation, we have to figure out, well, are we plugging the g of x function in for the f of x, or the f of x in for the g of x? So our inside function is what is being plugged into the outside. So the outside function is the last thing we do is take the 3%. So we're looking for f composed of g of x. Okay, so inside of this function, we're replacing the x with this function. And that will get us what we have up there to begin with. How we figured out we would do this problem in the beginning. So first of all, we're subtracting $500,000 if our sales are above 500,000. And then after we do that, then we take it times 3%. Okay? So that's an example of composition of functions. So let's break this next one up then. Let's say we have this function. We have h of x is equal to 1 over x minus 2 quantity squared. Okay? And let's just try breaking this down. Well, notice in there that we have a function embedded inside another function. So we can, let's say, f of x will be the inside function. Okay? So what I would do first is take a value and subtract 2 from it. And then, after I get that value, I would square it and then divide it into 1. So you see how this is a possibility of those two functions? So the notation we would have then is f composed of g. So we'd have to do the inside function, I wrote that wrong because I just switched it around. I told you the f of x. Sorry about that. Cross that out. This is the inside function. So that is going to, the f of x is going on the inside. And then, after we calculate that, we square it and divide it into 1. So there's our composition. So another way you could see that is like this. Those two would mean the same thing. Okay? So there are some examples of composition functions, and then also just some of the basic stuff, adding, subtracting, multiplying, and dividing functions as well. Okay? All right, very good. We're just about getting done with some of the basic things that we've talked about before with functions, well, like in Algebra 2 talked about. All right, see you in class.